lesson 7.4, coordinate proofs part 1. Now we've been doing a lot of proofs with quadrilaterals when they're not on the coordinate plane. Now we're going to prove that things are parallelograms and rectangles using the coordinate plane. So if I know the coordinates of all 4 points of a quadrilateral, how can I prove that it's either a parallelogram, rectangle, square, or rhombus? We're going to go through that. Now the first thing we're going to do is prove that a quadrilateral is a parallelogram, all right, on the coordinate plane. The way we're going to do this, and hopefully you're thinking ahead a little bit, we're going to use one of the properties of a parallelogram. And the property that we're going to use is that opposite sides are parallel. All right? We know that in every parallelogram, opposite sides are parallel. So to prove it, I have to show that the opposite sides are parallel. And how can I do that? Well, by finding the slopes of all 4 sides. All right? Now you can use the slope formula, which we'll do in a second, but I'm just going to kind of cheat here and just do the counting method. So to find the slope of AB, all I'm going to do is just find any 2 points on this line. We got one here and one here. And let's count the slope. It's up 2 and over 3. All right? 2 over 3. So the slope of AB is 2/3. Now let's find the slope of DC and see if it's parallel. Once again, I'll find 2 points. I got a point here and a point here. So I'm going to count. It goes up 1, 2, and then over 3. 2 and 3. So once again, my slope of DC is 2 over 3. Let's find the slopes of DA and BC. So of AD, let's find 2 points. I have a point here and a point here. So that's down 1, 2, 3, 4 over 1. So that's 4 over 1, and it's a negative slope, so that's negative 4 over 1. And let's find the slope of BC. So I'm going to find 2 points, and I'm going to count 1, 2, 3, 4, and over 1, 4 over 1. So the slope of BC is negative 4 over 1. So if you look here, let's use some coordinate colors. We know AB and DC are parallel, and we know AD and BC are parallel as well. All right, so now we're going to write our conclusion, just like we've done in all our proofs. And our conclusion is just that in quadrilateral ABCD, I know that AB is parallel to DC, and AD is parallel to BC. So I showed my work, I write my sentence. Therefore, ABCD is a parallelogram because opposite sides are parallel. And just like we have been doing, we're just going to write our property right there. All right? So let's do another one of these. All right? We're going to do another proof. So in quadrilateral PSFT, it has coordinates P blah, S blah, F blah, F and T blah. I shouldn't say blah. Those are all coordinates. We're going to prove that PSFT is a parallelogram. So let's start by plotting our points. We have negative 5, 1. S, that's P. We have S, negative 2, 2. That is S. We have F at negative 1, negative 3. That's our F. And then we have T at negative 4, negative 4. And that is our T. We connect them, and we have a beautiful looking parallelogram right here. Now we got to do our proof, right? We're going to show that opposite sides are parallel. So first I want to start by finding the slopes of PS and TF. And the way I'm going to do that is I'm just going to use the slope formula this time. Now you can count, that's totally valid. I'm totally happy with that. But you can also use the slope formula, which we have nicely written out here. So to find the slope of PS, let's use this P and S. All right. So Y2 is 2. Remember that's Y2. Y1 is 1. X2 is negative 2, and X1 is negative 5. If you do 2 minus 1, you get 1. If you do negative 2 minus negative 5, let's see, you get 3. So the slope of PS is 1 over 3. Let's do FT. Well, I'm going to go and find my points F and T. All right, so we got F and we have T. So Y2 is negative 4, plugging into my slope formula. Y1 is negative 3. All right, Y2 minus Y1. X2 is negative 4, and x1 is negative 1. So let's do this. Negative 4 minus negative 3 is negative 1. Negative 4 minus negative 1 is negative 3. A negative divided by a negative is also positive 1/3. So look, I proved that PS and FT are parallel. We're going to do the same thing for SF and PT, but you know what? I don't usually do this, but I'm going to say, pause the video and try filling this out by yourself, all right? And then come back and see that if you got this correct. So try to find the slopes of SF by yourself and PT by yourself. And then if you really want to be ambitious, fill out this conclusion all by yourself. So pause the video now. I know you still didn't pause it, so pause it. I said pause it. All right, you're not going to pause it. No, pause it. All right, come back in a few seconds. I'll have the answers for you. All right, so if you did your math correctly, you actually paused your video. When you plugged it in, you got the slope of SF is -5, and the slope of PT was -5 as well. So to write your conclusion, well, let's see. We found out that PS and FT, these two are parallel to each other. And we also found out that PT and SF are parallel to each other. So in quadrilateral PSFT, we know PS is parallel to FT. And we also found out that SF is parallel to PT. All right, and we have all our work right here. Therefore, PSFT is a parallel because opposite sides are parallel. Okay, so we got that down. All right, for the second part of this lesson, we're going to prove that quadrilateral is a rhombus. And we're going to do this in 2 steps. The first step is just to do exactly what we've been doing. We're going to first prove that it's a parallelogram by showing opposite sides are parallel. That is your first step. Your second step is to prove that it's a rhombus by using one of the properties of rhombus. And for now, we're going to show the diagonals are perpendicular. Okay, if we can show the diagonals are perpendicular, then we know it's a rhombus. So it's 2 steps. First one we just learned, the second one I'm about to show you. So let's first prove that this is a parallelogram. And I'm going to do the same thing I just did. I'm just going to use the counting method. So to find that opposite sides are parallel, let's start with AB and DC. All right, and I'm just going to count it. So to find the slope of AB, I count up 1, 2, 3, and then over 1, 2, 3, 4, 5, 6, 7. So up 3 over 7. Now let's find the slope of DC. So we go up 1, 2, 3, and then we count over 1, 2, 3, 4, 5, 6, 7. 3 over 7. So the slope of DC is 3 over 7, and we just proved that our first pair of sides are parallel. Let's do that again. All right, so now we're going to prove the other sides are parallel. From C to B, it's up 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. So this is up 1, 2, 3, 4, 5, 6, 7. So that's 7 over 3. And then our next one is up 1, 2, 3, 4, 5, 6, 7, and then over 3. 7 over 3. All right. So we got a good parallelogram looking thing going on. So we just proved that these two are parallel. So we know that this quadrilateral is a parallelogram because AB is parallel to DC and AD is parallel to BC. Therefore, ABCD is a parallelogram because what we've been saying, opposite sides are parallel. Now we got to prove that it's a rhombus. Since we know it's a parallelogram, now we got to show that it's specifically a rhombus. And we're going to show that the diagonals are perpendicular. So let me erase all this right here. Let's get rid of it. We already used that. And let's show what the diagonals are. We have D to B. That's our first diagonal. All right, so we're going to find the slope of that. And then we have AC. So let's start with DB. The slope of DB is up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I'm going from D to B, and then it's over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the slope of, let's see, DB, why does it say AC? Hold on one sec. Sorry, BD, that's exactly what we're looking for. Slope of BD is 10 over 10, which can be reduced to 1. Okay, now let's find the slope of AC, which is right here. It's down 1, 2, 3, 4. Oh, just down 4. and then over 1, 2, 3, 4, and then over 4. All right, and so that's negative 4 because it goes down over 4, so our slope is negative 1. And so negative 1 and 1 are reciprocals of each other. So we know parallelogram ABCD is in parallelogram ABCD, we know that AC is perpendicular to BD. We just proved that because the slopes are reciprocals of each other. Therefore, ABCD is a rhombus because diagonals are perpendicular. And remember, you have to have your conclusion. You always got to write your conclusion. Even after you do all your math, you got to write your conclusion there. That states the property. Now for our next one, what I'd like you to do is kind of do this on your own. Find all these slopes, write your conclusion to show that's a parallelogram. All right, start there. Let's do that together. In fact, first plot these points and find all your slopes and pause your video. And let's see if you do that correctly. Okay, so find all the slopes and then write your first conclusion to prove that this is a parallelogram. And then we'll move on together. Okay, pause the video now. So I don't know how you did it, either use the counting method or use a slope formula, but you found all of these slopes and then you wrote your conclusion. In RO and MY, RO is parallel to MY, okay, we found that these are parallel, and OM is parallel to RY. Therefore, you always have to write out this whole conclusion. ROMY is a parallelogram because opposite sides are parallel. Now on to the second part. So that's step 1. Now we got to show that the parallelogram is a rhombus by showing the diagonals are perpendicular. So let us do that now. So we're going to show that RM, find the slope of RM, and so that is 1, 2, 3, 4, 1, 2, 3, 4. So that's 4 over 4. All right, and then YO, you can count that yourself. Okay, but it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 over 10. But that is negative. So this is positive 1, this is negative 1. And so our conclusion, we know in ROMY, RM is perpendicular to OY. Therefore, ROMY is a rhombus because diagonals are perpendicular. All right? Actually, let's just write that up. Perpendicular. So remember, you have to do both. First, you show that's a parallelogram. Then you show that it's a rhombus by proving one of the points. And you always write out your conclusions, guys. All right, that is it for this lesson. Well done.